Hi there. Welcome to lesson 9.2 for pre-calculus. So today we're going to learn about arithmetic sequences and partial sums. So what do I mean by an arithmetic sequence? When consecutive terms of a sequence have the same difference, so they are the same amount apart from each other, it is considered to be an arithmetic sequence. So for example, we've got the following sequence: 7, 11, 15, 19, 23, 27, and it goes on and on. So we can see the difference between 11 and 7 is 4. Between 11 and 15, 4. 15 and 19, 4. 19 and 23, 4. 23 and 27, 4. The difference between each of the terms, consecutive terms, is the same. It's 4 in this particular sequence. So because the difference between every single term is the same number, it is considered to be an arithmetic sequence. Okay, so because it's one of these types of sequences, we can find out specific pieces of information. We can find any term in the sequence with the following formulas. So these two formulas right here, there are two formulas listed. Either one can be used. So the nth term, and that's what we mean by a sub n right here, can be figured out by d, which is your difference between the terms, times the term that you're looking for, so whatever term that is, plus c. And c can be figured out by taking your first term and subtracting off the difference. So let's take that into account with the sequence that we had above. So we want to say, let's say we want to find our third term of this sequence. So n equals 3. We need to find the difference, which we already found that from the previous example. Our d equals 4. The difference between these terms was 4, every single one of them. And then c, based on this formula, says that it's going to be our first term minus our d, which is 4, which equals 3. Okay, so if we were to plug this into our formula, our third term of our sequence will equal d, which is 4, times n, we're finding our third term, plus c, which is 3. So that gives us 12 plus 3, which is 15. And we can see that our third term in the sequence is in fact 15. So the formula did give us our third term. Another way that you could find whatever term you're looking for is this formula right here. So these are just two different formulas to find the same thing. So this would be if we didn't want to solve for c. Then we would use this second formula here. So using this formula, our third term can be found of taking our first term value, which is 7, plus n minus 1, so n equals 3 in this case, 3 minus 1, times our d, which was 4. So this gives us 7 plus 2 times 4, which is 8. So 7 plus 8 is 15. And again, it gave us our third term value because we were looking for the third term. So you're going to want to use these formulas in your homework to solve for whatever term that they ask for. All right, moving on. So we can also find the sum of arithmetic sequence, whether it's finite or infinite. So the sum of the sequence can be found of a finite sequence. Now, finite means that it has a last term. It has a value for the last term. It doesn't just keep on going. The way that you're going to find that is your sum of whatever sequence that is equals however many terms divided by 2 times the sum of the first term plus the last term. So, for example, let's take our sequence again. If this were a finite sequence, in the case that it ended right here, this was the last term, we see that we have 1, 2, 3, 4, 5, 6 terms, so n equals 6. So if we wanted to find the sum of this sequence, we could simply add all these together. it wouldn't be too bad, but as n gets bigger, adding all these terms is not so easy. So we're going to use our formula. So we want to find our sum of our finite sequence where n equals 6. There are 6 terms. So that means we have 6 divided by 2 times the sum of our first term, which is 7, plus the last term, which is 27. Okay, so that means that we have 3 times 34, which will give us 102. So the sum of this sequence right here is 102. If we were to add up all of those terms together, we would get 102. Now, we can also use this formula if we have an infinite sequence, but we want to find the sum of the first however many terms. So, for example, if this sequence continues on, but we wanted to know the first 50 terms of this sequence, we could use the same exact formula. And you would do that. Just as we did here, n would equal 50 instead of 6 if we're looking for the 50 terms. So you can use it to find the sum of an infinite sequence, but only through however many terms are specified. So it in fact becomes a finite sequence. And it has to be the first terms. You can't find it somewhere in the middle of the sequence. It has to start with the very first term. Okay, that is it for today. Super short lesson. I hope you guys enjoyed this and look forward to seeing you soon. Take care. Bye-bye.